Okay, coming up. Oh, hey, so we don't have the talk title here. I think in the notes it's Revolutionizing Chatter in RTS Gaming in Homeworld 3. And that was a title that our marketing person came up with. And I said, I don't think we really did revolutionize the chatter. I think we just did a really good job. And he said, yeah, you can't say that. So I didn't say that. So I was the presentation lead software engineer for Homeworld 3 for most of its development. I started off as the lead audio programmer and then took on some extra responsibilities, mostly because it was felt that anything that wasn't the sort of the gameplay, what we call the presentation, which encompasses the UX, the speech, basically anything non-gameplay related that needs to be communicated to the player, is the presentation side of things. But we wanted that to work tightly together. In some of our previous games, there was not a lot of communication between like VFX and sound effects and UX and sound effects. And we thought that having a group where having the UI and the VFX people and the sound effects people all communicating more often would hopefully help the game cohere pretty well. And I think it did. Like we especially got good reviews in the areas of visuals and speech and sound effects. So I think that approach really helped, and I would definitely recommend it for the future. So this, just to give you a bit of context about the game, it's a clip of the game in a sort of high combat firefight situation where there's a lot going on, and yeah, I'll just let it go. So for this, I actually took out all of the scripted speech and then just let the speech systems, the ones that were responding to just events in the game and things happening in the game, kind of work by themselves. And I think overall, like, it does a pretty good job of communicating the intensity of battle and like the sound of a bunch of people under pressure, like military personnel communicating with each other. Next slide. So sort of overarching design goals with the speech and the chatter specifically, that was the biggest one. Like, we wanted it to feel like people. I think RTS is generally, the sort of Warcrafts and Starcrafts, they've come from this sort of very gamey perspective, and everything is very fast-paced and clicky, and it's more like you're moving units around on a board. It's not like you're watching a real thing happening. With Homeworld, we wanted it to be almost incidentally an RTS. We wanted the space fantasy and the feeling of it being a fleet of people working together, that to be the main thing that they were selling, like less so much the simulation aspect. And a big part of how we sort of managed the complexity of that was just to break the speech down into a few different categories. Like this at the top level, orders and notifications. That's really the sort of stuff you would get in your traditional RTS. What they call barks, usually in an RTS. They're short, they're sharp, they're informational, they're just getting across, confirming that you've done something, and then letting you know when the people or the units that you're ordering to do things have happened. Like maybe some research has been completed. Maybe you've taken some damage. Maybe the ship's health has changed. It's purely information. There's a little bit of world building there, but it's not really the focus. So what was more interesting to me was the amount of chatter we added. We broke the fleet down into sort of a communications structure, like a bit like a military. You would have the main fleet command, which is nominally you, the player. And then we had formations of like a little group of speech voices that were working together. So pretty much like you would have in a real military situation. There's kind of a chain of command, and that informed how we wrote the dialogue and how we broke it down into specific categories. So a lot of the chatter that we have, the units will talk to each other, and we actually ended up putting individual crew members into the ships. Originally, when we started off, we had a voice for each single ship, and that was sort of a one-to-one mapping. It was just, this ship has this speech, and that's what you always hear when you click it. And we realized that wasn't really a good representation of how you have real vehicles or real flight vehicles. Like if you look at something like Top Gun, you've got like guy in the front, pilot, the guy in the back, the tactical officer, and they're always chatting back and forth to each other. They're chatting to other people in their flight crew, and we wanted to get some of that feeling across in our designs. So a bit of an aside, as a programmer, which is my background, I like things to be kind of like logically consistent. The more I understand about a category of things, the more I can reason about it, and the more I understand it, and the easier it is for me to program and to implement and to work with other people who are working with this. So I talked to our designers and asked them a bunch of questions to try and figure out what they were thinking. Our designers are very, or at least our lead speech designer, Dave, he's very, very creative, often to the point where I don't always understand where he's coming from. So we needed to get on the same page. I needed to understand like the emotional angles that he was going for, and he needed to understand the technical requirements that I had when programming things. So we sat down and we asked each other a bunch of questions, like how important is this area of speech to gameplay? How many of these things are there going to be? How long do these things last? And like by the end of that, I felt like we had a pretty good understanding of where each other was coming from. And it also helped me and Dave figure out how we could mix these situations, which could be very, very variable. In the game, you can be zoomed right in on a single player, on a single fighter, or you can be zoomed way out and you can see the whole fleet at once. And we need to have a system that can manage those two like opposing ends of the spectrum. So we used the same approach with speech for sound effects and VFX. I think it was especially helpful for VFX because, like, let's say you're culling VFX and you've got some category settings on there which tell it how long it's going to last or when it's going to cull. If all of the VFX in your category are really short and they should be culled easily or culled at a distance, and then you throw like a couple of looping things in there, like the more coherent your categories are, the easier it's going to be to validate the behavior and to test it. So when we were sort of spitballing our initial ideas for chatter, it was very ambitious. And the final design that we ended up with, I would say, was a lot simpler. And the main reason I want to talk about that is, like, especially if you're working on an indie game or a lower budget game, often the simpler design is going to be the one that actually serves your game better. Our initial complicated designs were great, and we had fun prototyping them, and they did all sorts of cool things. And then we realized, oh, we're doing these things not because it's great for the game, it's because we're nerds who like playing around with complicated systems, which is fantastic. But you really want to make sure that the things that you're building fit well with the game that you're building, especially audio, whose job really as a discipline is to help serve the rest of the game. Going off on these weird tangents where you've built these crazy systems is not always the right thing to do. I will tell you about some of the crazy systems we did later, but that was, we had reasons for those. So the final design for dialogue was actually very, very simple. It was mostly built around calls and responses. Initially, we had like very long, like RPG-like conversations where they would branch and you needed to track all sorts of state, and it was very confusing. And we found that, oh, actually, you don't really hear any of these things in the game. Like the game is too complicated for these to come across, and that dialogue design, we're having a lot of extra complexity, like technical and recording and design, which is just not adding anything. So we stripped it right back to, we just have call and response. That suddenly made it a lot easier to write for. It made it a lot easier to create variety because we could just have simple categories of this call event is paired with this response event, and we can randomize all of these lines in this particular event and response event pairing, and they sort of fit nicely together. What really helped us with that is sort of realizing that honestly, a lot of the dialogue in Homeworld it's in that sort of Star Trek space gibberish space where you're like, oh yeah, he said something. That seemed, those were words, cool. So that really helped us on the writing side. So what we did do to try and keep some of the feel of those specific long branching conversations was we cheated. We took some pre-written dialogue and we baked it into a long sequence, and then we would just play it out. And because you're on a ship in space with all sorts of stuff around you, you can't necessarily tell where the sounds are coming from. So I set this up in our sort of like test audio gym. Like obviously the very, very large dialogue is not in the real game. This is just for your benefit, but this is a quick example of the lines are just the event that's being called. The voice is the particular voice that's on the ship, and then the text is what they're actually saying.
Ready to copy. Coming around. Track ready. Quick ID. All contacts. Okay. Stream buffer responding as expected. Link for update now. Signal's clear. 2-1. Switch to TAC 3.
Understood. Switching.
Offset weapons. Narrowing funnel.
Do you mean widen?
Correction. Widen funnel. Say again. Widen.
So that last line, apparently one ship's saying it, but it's actually having this long conversation with an off-screen sort of third party, but it doesn't matter. You can't really tell. It's broadly sort of modeling radio communications anyway, and you don't notice it. You barely notice it when there's just 3 in a black void, and when there's millions on screen with things exploding, it works very, very well, and it's a lot easier to manage than a complicated system. Talking about the back end a bit of like the things that we had to consider when writing the speech, a lot of what we needed to be concerned about was, well, where are we going to get the information from to make the speech contextually appropriate? There's a lot of stuff we can pull from the simulation, things like the ship types, what the ship is doing, whether the ships are allies or they're hostile ships, and whether they're near to like particular like objects. Just to clear up nebulae and megaliths, those are sort of 2 Homeworld 3 terms of art really, where nebulae is like the big enormous space clouds that we can hide ships in, and megaliths are just like the huge environmental structures. So if you're in those or you're near those, we want the speech to be able to comment on them. All of that state is stored in a Blackboard for the ship, so we have access to it and can like use that as part of choosing the particular lines that we want to say whenever a ship says something. Okay, so looking at, like, here's a quick example of what our data setup looks like. You can see for a specific voice, we have a bunch of events. Those are all the different use cases, like all the different things that might happen in the game that we might want to comment on. And then for each event, we have a bunch of different states. Those are things that we can pull off the Blackboard and then figure out, okay, an event has happened, given the state of the ship, what should we say? And then eventually that gets mapped down all the way to, okay, we've chosen a specific random line that works well in this scenario. One of the things that was a lot trickier to work out was actually how much combat a given ship or fleet of ships was in. And that's something we'd handled before in Crossfire Legion. That was a more sort of traditional 2D RTS. So we had a similar system for that. So this is a system that's been sort of evolving for a while. We had an influence map where we would track weapon events. We would track the range of effective fire of a weapon. We'd track how much damage it would do. And then we'd sort of bake all that information down and then cluster it and then work out just by doing a raycast downwards, like this is how much trouble a ship is in. And we did kind of a similar thing really for Homeworld. So obviously it's a 3D game. Influence maps aren't going to work. You'd need like a huge voxely thing and it would just be a terrible idea. And so what we did instead was we tracked all the ships, we tracked what they were targeting, we tracked the range of their weapons, we tracked when they were firing, we tracked what type of ship they were, and then we just bounding sphered those. And then that was enough basically for us to figure out, are we in combat? Are we near combat? Are there a bunch of ships nearby us which have incredibly powerful weapons which could kill us instantly? And that all gets baked down to, it's really just like 3 different levels. I think there's clear, which is you're not in combat, everything is fine. Everything that we recorded for clear is very even, like they're not even under pressure, they're just chatting back and forth. They're very relaxed. Alert, if we're within range of one of these combat hot zones, then we sort of crank up the pressure on the units a bit. They start to get a bit shorter, a bit sharper with each other. They realize that they're, they're readying themselves for a combat situation. And then combat, they're actively engaged in combat. So they're still pretty, they're professionals, so they're not yelling and screaming at each other, but they are, they're keyed up, like, and you can tell that they're in combat. And the nice thing about having this one system to figure out how much combat was happening was that it could be used by a lot of things. It was used by the UX to tell you, okay, here's some like red flashing arrows on the side of the screen to alert you, oh, there's combat happening over here. The same system was used by the music to figure out, oh, how much combat is happening on screen? What level of intensity should we have in the multi-layered music? And the fact that it was sort of one system providing all this data, so it kept everything in sync, and I think made it cohere a lot better than it otherwise would have done. This is just a quick clip of like sort of what that system looks like under the hood. You can see it tracking the individual ships. You can see it making these pairs of ships that are targeting each other. You can see the bounding spear of the whole area. And you'll see, like, as the two come together, they'll just gradually get merged into one combat area.
Sensor alert. Enemy destroyer. Increase throttle. Taking heavy damage. We're in overload.
Okay, I think I may have rushed through this a little bit quickly. There's a lot of things that we didn't talk about, but the area of speech, like creating the speech on Homeworld 3 was actually, it was a huge process. There was mixing ongoing throughout the whole game. Recording was a huge part of it, like casting, making sure we had the right people. I think we had 3 rounds of recording where we initially started off with assets from previous games to prototype things, test things out. We had some initial recording which was done with in-house talent before we went to real recording, again, just to figure out that things worked and we were getting the tone right and that the writing was sort of starting to make sense. Testing was a big part of it. We spent a fair bit of time developing some custom testing tools. Like, the more complicated a design gets, I think the better your testing tools need to be. Like something like this, where it's a relatively complex system where you can have all sorts of different things happening in a mission, becomes incredibly hard to sort of test in situ. So we needed to have some way of confirming, like, okay, is the content for this, like this piece of speech isn't working. Why is it not working? Is it the gameplay that's not sending the right events? Is it the speech content? Does that fail to package? Did we forget to even record that? Is there a naming error somewhere? So there's like basically 10 or 15 different places that things can go wrong to result in a sound not playing, and having some tools to be able to quickly confirm, oh yeah, this file's not even on the disk, that's never going to play, or oh, the gameplay isn't firing off the right event, that's never going to play, and then going on a checklist all the way from A to B. If you're trying to do that just with bug reports and just with the live game, it's going to take you forever to fix things. Wise setup, I'm not the sound designer, so I can't speak too much about that, but we did invest like a lot of time into having our own custom culling technology. There's so much stuff happening on screen that Wise's own like just channel limits weren't really enough. Like I think it's the command buffer in Wise would actually get full and fall over, and it would just spend too much time trying to rip out sounds that were just never going to be played anyway. So we had some custom culling algorithms on top of that. We used custom DSP plugins, which is actually a super fun thing to do if you do use Wise. There's it's more, this kind of thing's more accessible now in something like Unreal, where they have like the whole new meta sound system. So that has the DSP blueprints essentially just kind of baked into it, but we were using Unreal, we weren't using Unreal 5 with meta sound. So if you wanted to do custom DSP, we had to basically write our own. We used a thing called Heavy, which lets you use max MSP patches and then bake them down to C++ and then run them within Wise. And you can still do that, but it's a lot easier if you can use something like meta sounds. It's a fiddly process. Another big part is like how the speech interacts with the rest of the game. Like it's not the whole game, and it's not even the whole story for speech. There's cinematic speech and campaign speech, and sort of making sure that the game, like the systemic game chatter, was working well with those types of speech was another pretty huge challenge. So there's a lot of other things I could sort of dive into, but I'm a little bit more interested in like if anyone has any questions, because I'm interested to see what you think. Oh.
On the left. Hi, so a simple question. So for writing the interactions, did you try to have any little kind of did you try to carry any sort of narrative with the background chatter, or did you just try and like make it like flavor? Like, what was your?
No, I mean, that's a really good question. So the way we sort of approached narrative was actually at the event level. So there's a really good diagram that our sound designer sent me yesterday, and I was like, oh, this is great. I wish you sent me this a week ago, and I could have just thrown this up on the screen. But he actually spent a fair bit of time like trying to take the game flow, like from something as simple as, okay, you've selected your unit, you're flying to where they need to go. They've arrived and then they get attacked, and all of a sudden it goes from like a quiet situation to a full-on like combat breakout. So where sort of narrative came into the game was more sort of tonal narrative, where we tried to make like little stories of what we expected to happen in the game, like expected game conditions that would come up, and then kind of write linear narratives for those, and then turn them into event sequences. So as you're playing the game, hopefully like these little mini stories kind of emerge out of the events that are being fired. Like rather than having specific conversations that are authored about specific things, we wanted them to just kind of naturally come up. And that, I think, was something that the pre-rendered conversations really helped with, because once your ear has heard a few of those pre-rendered conversations, you're now looking for conversations that are happening. And sometimes you'll kind of identify, oh, I think this is one of those conversations, but actually it's just something that fell out of the recorded content. So the pre-recorded longer stuff actually kind of helps trick your brain into thinking, yeah, there's real conversations happening here.
Nice.
Oh, sorry.
You mentioned that on screen you had here, you had a lot of sounds happening at a lot of times, and for optimization purposes, my question was if there were cases where certain sounds got priority in how much fidelity you were giving them, just for like size of the game, like cases where you were using waves for some that were high priority and maybe .oggs or even lower fidelity kind of formats, just to save on space with the amount of sounds that you guys were using in game and all at the same time.
We were actually quite lucky in that, like we had enough sort of memory budget and recording budget, and that like that didn't have to be too much of a concern. Like it was more sort of a mixing problem where we had to work out, well, we've got so much stuff happening at once. Like, how do we keep this clear? We don't want to like just bombard people with sounds. We want to try and make it relatively legible what's happening on screen at any one time, and that was a big challenge. Like the mixing is, I think, still happening to this day, like trying to wrangle it into a really clear format.
Thank you.
Oh, and I've been told there is no more time for questions. Just a quick note. I did get a mail from a producer saying that we have like a number of Steam keys of Homeworld 3 available. So if you want one, email me, and if you're in the first whatever number it is, then hopefully I can get those to you. Thanks very much.